triangle. So remember that the way they got that number, that seemingly random number, is they weighed out 12 grams of carbon-12, and that was this where they got this number from, the 6,02 times 10 to the 23. Which means if you look at any element on the periodic table, so carbon, the mass is 12 at the bottom. That's why they weighed out 12 grams. They didn't want to work out the number of atoms in like a random amount. They wanted 12 grams there. So if you look at 1 mole of, let's say, oxygen, it would then also weigh, well, that's a bad example because that's diatomic, let's say boron. That would also weigh that bottom big number. So it would also weigh 11 grams per mole. Okay? So the number at the bottom gives you the mass of 1 mole of that substance, okay? So in other words, we can rewrite this as 1 mole of carbon weighs 12 grams, okay? And 1 mole of, let's look at a couple, okay? So 1 mole of boron, like I said, would weigh 11 grams. So 1 mole of boron would weigh 11 grams. And 1 mole of magnesium would weigh 24 grams. So the number at the bottom is always going to give me my mass, okay, of 1 mole of a substance. Now you call that the molar mass, okay? That big number at the bottom used to be just the mass of 1 atom of the substance when you measured it in atomic mass units or units. But if you measure it in grams, it's the mass of 1 mole of that substance. Okay, so it's the big number at the bottom. Careful though of diatomic elements. So a diatomic element like oxygen, oxygen weighs 16 grams, but that's 1 little oxygen. Now oxygen doesn't like to be by itself, so oxygen always bonds to another oxygen. So actually 1 mole of oxygen, and we should write it as O2, weighs 32 grams. Okay, let's write other diatomic ones because that's easy to forget or confuse. So 1 mole of fluorine wouldn't weigh 19, it would weigh 19 times 2, so 38 grams. Okay, so be careful of anything diatomic. 1 mole of nitrogen would weigh 14 times 2, so 28 grams. So anything diatomic, that number on the periodic table is the mass of the 1 mole. Yes. Someone want to ask something? Okay. Now, let's look at a triangle of this. Okay, so you want to get the mass. I'm just going to mute because I just hear a little bit of noise. You're welcome to unmute yourself if you want to ask anything. Okay, so if you wanted the mass of 1 mole of a substance, you will go the mass, small letter m, is equal to how many moles you have times by big letter M, okay, capital M, so molar mass. So if you had, for example, let's change this a bit, let's say that you had 2 mole of, let's say, boron, then it would weigh 2 times 11, so 22 grams. Let's say that you had 10 moles of carbon, then it would weigh 12 times 10, so 110 grams. So where you get this little m from is you take how many moles you have, times it by the mass of 1 mole, in other words, the molar mass, on the periodic table. Okay, so let's get some other questions up here. Let's turn it into a triangle first, actually. So mass is moles times molar mass. If you want to turn that into a triangle, m, little m goes at the top, then n, and then big M at the bottom. This stands for mass, measured in grams. Now be careful, that's the one big difference in physics and chemistry. In chemistry, we measure mass in grams, in physics, we measure it in kilograms. Big M stands for molar mass. Okay, you get that straight from the periodic table. Okay, you can't write chemistry anymore without periodic table, so it's the big number at the bottom. So carbon is 12, boron is 11. Just be careful of diatomic elements. You'll have to times their molar masses by 2 if you want to work them out. And then little n just stands for mole again. So let's start with a question together, and then I'll give you guys some time to do one by yourself, or a couple by yourself. So let's work out the mass Okay, so the question is calculate the mass of the following. So let's say that you have 2 mole of, say, calcium, and you have to work out the mass of 2 moles of calcium. Okay, I'll give you guys a minute to do that. So I'll just add another one. If you had 5 mole of, let's make it NH3, let's make it something different. Okay, you guys can try those 3. You're working out the mass, little m, of 2 moles of calcium, 5 moles of NH3, and 3 mole of oxygen. To start these, so the question is to calculate the mass if you have the following number of moles. So this is your second mole triangle. So for the first one, my mass, little m, is equal to mole times molar mass. The mole is 2. The molar mass of calcium, if you look at your periodic table, okay, calcium is the big number here, so it's 40. Okay, so it's 2 times my 40. That gives me 80 grams. Okay, so that's the mass of 2 moles of calcium. Then number 2, 5 moles of NH3. Actually, let's do that one on the side here. So 5 moles of NH3. So then we'll go mass is moles times molar mass. Okay, now NH3 is made up of nitrogen and 3 hydrogens. So to work out that molar mass, I'll go, what's the molar mass of nitrogen? It's 14. Then what's the molar mass of hydrogen? 1, but there are 3 hydrogens there. So I'm going to have to times that molar mass by 3. So actually ammonia's molar mass is 14 plus the 3, so 17. Okay, so 5 times 17, you don't have to rewrite that. Okay, so 5 times 17 gives me 85 grams of ammonia. Okay, so be careful if they're asking you for a compound. You'll have to obviously work out the molar masses of each individual one. If they gave you something, I know one of the worksheets focuses on that a lot. If they gave you something like that, then it's the molar mass of calcium, which is 40, plus carbon, which is 12, plus oxygen, which is 16, but there's 3 oxygens in total there. So careful of anything where there's a molecule and you have to add all the different molar masses together. And if you have anything that is in a bracket, okay, so let's say that you had aluminium nitrate. What that means is aluminium, there's 1 aluminium, so the molar mass would be 27. Then careful of brackets, because what this means is there's 3 times 1, so 3 nitrogens. So there's, nitrogen is 14, but there's 3 of them. Then careful of oxygen, it's not 3 plus 3, it's 3 times by 3. So it's 9 oxygen. So you'll go 16 multiplied by 9 to get your molar mass for oxygen. And then you add all of that together, and that will give me the big M, the molar mass of that substance. Okay, so careful of anything where it's a compound and you have to add all of them together. Okay, then the last one here, calculate the mass of 3 moles of oxygen. I just put that one to remind you of the diatomic ones and to be careful of that. So oxygen's molar mass is 16, and it's easy just to forget to just leave it there. But remember, it's diatomic. So oxygen always occurs as O2. So you have to times that 16 by 2, so you get 32. So then 3 times my 32 gives me 96 grams is my mass of 3 moles of oxygen. Okay, I'm going to give you guys just 2 more of these before I move on to the next triangle, where now you have to work out the number of moles. So you're doing differently, okay? So now the question is calculate the number of moles. So you have to manipulate your triangle a bit. So always close what you're looking for. So if you're looking for mole, it's going to be mass divided by molar mass. Okay, so calculate the number of moles. If you have, let's say, 100 grams of calcium carbonate, and let's say that you have 20 grams, well, let's make it 200 grams of NaOH. Okay, so you're working out the number of moles if you're given that mass of calcium carbonate and sodium hydroxide in the second one. Guys, it done? Okay, so the question is calculate the number of moles in 100 grams of calcium carbonate and in 200 grams of NaOH. So like I said, if you're looking for moles, close that one in the triangle. So mole is equal to mass over molar mass. So the mass of calcium carbonate is 100. The molar mass is the masses you get from the periodic table. So this one is calcium. Okay, so calcium, which is 40, plus carbon. Carbon's molar mass is 12, plus oxygen, but there's 3 of them. So 16 times by 3. This is actually quite a nice one if you ever see it. Calcium carbonate's molar mass is 100. That's why it's always such a nice one to use in examples. So 100 divided by 100 just gives me 1 mole. Okay, so 1 mole of calcium carbonate would weigh 100 grams. Then the next one, calculate the number of moles in 200 grams of NaOH. So again, we're looking for the mole. So it's the mass over molar mass. So 200 divided by, sodium's molar mass is 23. Oxygen is 16. Now I'm not going to multiply it by 2 because it's not by itself, it's in a compound. Remember, it just doesn't like being by itself. So if oxygen's by itself, it always bonds with another oxygen and becomes O2. But if it's got other friends, then it's happy, it won't have to be diatomic. So it's just 1 oxygen and 1 hydrogen, and that gives me 40. Okay, so the 200 divided by 40 gives me 5 mole. Okay, it doesn't have to be nice numbers. I just chose nice round numbers, but it can be obviously 5.2 mole or 5.23, because remember, mole isn't molecule. Mole is a massive number of atoms. 1 mole is this many atoms. So you can absolutely get a fraction of that to work out.